All right, so the essential question we're seeking to answer this time is how can you graph a linear inequality in two variables? If you want to follow along, it's on page 268 in the textbook. And let's just do a little dissecting of this question. So we're going to end up graphing a straight line, right? But that's an inequality. So remember, when we talk about inequalities, we basically have four choices we can for inequalities. It can be the is greater than, is less than, is greater than or equal to, it's where it has a line underneath, and is less than or equal to. So those are the four possibilities. We know how to graph something when it's not an inequality, but what if it's an inequality and in two variables? So how do we graph a straight line when there's inequalities with an x and a y? Let's find out. That's a good question. So it says, tell whether the ordered pair is a solution of the inequality. We're going to do that. And another way to ask that question, or in other words, is what ordered pair makes this inequality true? That's how I would phrase the question. What makes it true? Well, let's work this out and see if it's true. So 2, but in place of the x, we can substitute what the x is. Remember, it's an ordered pair, so it's x and then y. So it'd be a 1. Oops, that's a negative 1. Plus, the y is a 9. Is less than a negative 3. We just brought everything else down. The only thing we put in was the negative 1 for the x and the 9 for the y. Okay, let's see what we get here. Negative 2, bring everything down. Negative 7, is that less than a negative 3? Well, it is. So the answer is true, and we see that it does work out. Very good. Let's do the next one and find out what we get here. So in substitute for the x, which one of these is the x? Well, it's the 2. And substitute for the y, which one's the y? It's the negative 2. Bring everything else down. We'll do our we'll do our order of operation. Is 8 greater than or equal to 8? Yes, it is. It's true. So in this case, we look at both of these, and they're both true. Oh, wait a second. Let's look back at this one again. A negative 2 plus 7 plus 9 is not negative 7. That's a positive 7. And is a positive 7 less than 3? No. So that should be false. Sorry for the mistake there. Positive 7 is greater than 3. That would be false. Whoops. Okay. Let's keep moving on. That's what I do when I make a mistake. I want you guys to take notes on these ones here. Label it 5.6a, and let's just try it again. So we'll have a 3. We'll substitute in the negative 2. Minus, but instead of a y, we'll put in a 2. Substitute. We have negative 6 minus 2 is less than 2. Negative 8 is less than 2. Okay, that's true. That means these ordered pairs will work for this solution. It's true. Notice that they're not the only right answers that would work. I could have put y to be 100 and x to be 0. Well, a negative 100 would be less than 2 as well. There's lots of right answers. That's why they vary. They're variables. There's also a lot of wrong answers. Okay, let's do this one real quick. 4, but instead of an x, we'll substitute the 1. Minus, instead of a y, we'll substitute the 3, because that's the y, is greater than or equal to 5. Does 4 minus 3, is that greater than or equal to 5? Is 1 greater than or equal to 5? No, so it's false. It's actually what we would say no solution. That is not a solution for that equation. All right, it's your turn. This is also in your textbook, but I want you to answer these 4 questions in your journal. Label it 5.6a. Try this, 1 through 4. Okay, write this next part in your notes, 5.6b. There's 3 parts to write down. It says graph a linear inequality in two variables. These are the steps on how you would do that. The first step is to graph the boundary line of the inequality and use dashes. The dash line for is less than or is greater than, and use a solid line for is less than or equal to or is greater than or equal to. I want to come back to this, but let's talk about what that means really quick. So remember, if you have an equation or inequality, I mean something like this. X is less than 3. All right, let me put a 3 on there real quick. It'd be an open circle. You draw the arrow, the inequality, because you don't include 3. It's less than 3, but not inclusive of 3. But if I were to have a different inequality, something like x is greater than or equal to -1, you would draw a closed circle because you're including the -1, and then you would draw your arrow. Well, we have to do the same thing when we're graphing with inequalities. When there's a coordinate plane, when you're going up for the y-axis and sideways for the x-axis. And so how we do that is with this idea of using a dashed line or a solid line. Just like a solid circle conveys that you include the number, a solid line would convey you include a number, whereas a dashed line would mean that it's the boundary line, but you're not including the number. Okay. So let me show another example. I'm using some vocabulary. I want to go over them. So this idea of a boundary line. If I were to put a line here on this, pretend this is straight, on this picture of the Earth, this would be called the boundary line because it's separating, and this would be one half plane. This would be the other half plane. I can even adjust this boundary line, say it was like this. Well, this now would be the half plane, and this would be the other half plane, and this would be the boundary line, the line of separation. So no matter how I moved it, it would just change the new half planes, no matter how I move the boundary line. So back to this. If I had a line, and I put a dot in between, a point, these would actually become two separate lines now, starting from this point, and they'd be called rays. This would be a ray. This would be a ray. But when you separate a graph, that's how you separate a line. If you separate the whole graph, meaning one side and then another side, this is called a boundary line. So a boundary line is what separates the two halves of a graph, and we call one half a half plane and the other half that is separated into a half plane. So okay, let's go back to these steps. So we're going to use a solid line if it includes the line, and a dotted line or dashed line if it doesn't. I'll show you an example of that in this lesson, maybe the one to come. We're going to want to do a test point that is not on the boundary line to determine whether it is a solution for the inequality. When the test point is a solution, shade the half plane that contains the point. When it's not a solution, shade the half plane that does not contain the point. We will show you how to do this, and then we'll talk about some strategies on what is a good point to choose for a test point. Okay, so let's look at this one here. It says graph y is less than or equal to 2 in a coordinate plane. So it's only giving us a y value. So we start at the y, 2, and we draw a line through it. Just like we would if we were doing y equals -2, we would just go up 2 and we would draw a line through it. But now we have to shade in a half, right? Oh, by the way, this is a solid line because it has the is equal to included. Had it just been y is less than true, the line would have been jagged. But we'll give you some more examples of that later. Right now it's is less than or equal to, so it's a solid line. So that's the first step, is we graph the boundary line. Next, we test a point that is not on the boundary line to determine if the solution if it's the solution to the inequality. What do you think is